Suppose R is a relation from A to B, and S and T are relations from B to C. Must the following statement be true? Justify your answer with a proof or counterexample. Okay. S union T composed with R equals S composed with R union T composed with R. So it sort of looks like we are distributing this little composition circle over the union from the right side, right? So, okay, the distributive laws, sometimes they're true, sometimes they're not, depending on what the symbols are. So we got to figure it out. And, well, let's make our table here. We've got these three relations, and that's our goal. And to prove equality of sets, we can okay, well, these are both compositions, excuse me, these are both relations from A to C, if you think about it. So it makes sense to use an ordered pair AC as a typical element. So we'll let that be arbitrary, and we got to show that AC is in the left side if and only if it's in the right side. Okay. And so to prove that biconditional, we could use our proof techniques, but the unions are pretty simple to write, or they just turn into disjunctions. And so I think we can try to do this one using, in fact I know because I've tried it already, we can do this one just using a chain of if and only if statements. Okay, so we'll start off our proof by saying we show that AC is in the left side if and only if it's in the right side, and we have, if you want to, you can put that in the next line, doesn't matter too much. Just move it over a little bit. Okay, good. We have that AC is in the left side if and only if, well, first of all, we have to deal with the composition, right? And so if and only if there exists a B in the middle such that AB is in R here and BC is in S union T. And then we have BC in a union of sets, and we know that means BC is in S or BC is in T. And now, hard to sort of keep these parentheses straight, but right, we have these two are together, and this one's sitting outside, and that's an and, right? And so we can distribute this sort of and over the or inside the parentheses. And so we're going to get the first statement and the second one, or the first statement and the third one. That's what you see on the next line. Okay. Maybe I should have used some square brackets there to make it a little bit easier to tell these parentheses apart. Anyhow, now we have a group of two here and a group of two over here with an or in the middle, and we have a there exists B out front. And if you remember, existential quantifiers and ors, they kind of go together, right? You can distribute an existential quantifier over an or. And so that's what I'm doing in the next line. I'm just taking this there exists B and I'm putting it on the first half and putting it separately on the second half. By the way, for all B and an and would also distribute like that, but you don't want to mix them up in the other ways, okay? All right, and then once we're here, well, these are, each half is the definition of something being in a composition, right? This one says that AC is in S composed with R, and this one says that AC is in T composed with R. And so we have this ordered pair AC, which is in both of those, excuse me, is in one or the other. There's an or in between, and therefore it's in the union of those two sets. Okay? And that finishes the proof.